hey everyone, let's check out this number 4. So number 4 is definitely one I would give people to start on their own and then jump in where they get stuck. So pause, try it out, usual thing. I know I say that way too much, but I also know that you probably ignore me way too much. So here I'm actually giving you the substitution, and I want you to try it in each case and see if you can get through the integral and what you end up with. Okay, so first one, I want you to try u equals e to the x, and we'll go ahead and use the u here even though I've been trying to stick with w's. The truth is you can use whatever variable you want. So if this is true, then du dx is also equal to e to the x, which means I could replace e to the x dx with du's. Okay, so back to this integral that I'm working on. I have a lot of things I could do. So one thing that I'll see sometimes is 1 plus, what is this? E to the u is this. And then sometimes people get a little stuck here. But one thing, oops, I'm lying to you if I say that this is still a dx. That's not a du yet. So sometimes people get a little stuck here. And one thing that you should notice is that if e to the x is really equal to u, then down here we could say that u replaces e to the x and the u dx is equal to du. So now we could say e to the u over 1 plus e to the u equals, no, not equals, du. You can fix that right away without the extra step if you just recognize that you want to keep these two out and replace those with your du. That's fine as well. But I'll see a lot of people get themselves stuck by putting all these u's in and then not realizing that your u dx is the same as your e to the x dx. Okay, so I actually want to get all the way through and see what happens here. So that was great. I did get rid of all of my x's. I don't know that it was incredibly helpful so far because that's still not a basic function to integrate. So at this point, I actually think I want to do a second substitution. My second substitution, the only composition I have now, is that bottom of the fraction. So I've mentioned this one a lot, and here you actually get to see it. Whenever you have stuff in the bottom of a fraction, that's a potential w, a potential inner function, because you could think of it as composed with 1 over x. So I'm going to do another substitution, and I'm going to say 1 plus e to the u is equal to w, which means dw, derivative of w with respect to u, is just an e to the u. And I can move that up and say, okay, well then I'm going to replace e to the u du with dw. So now, e to the u du, I have a dw, whoa, things went crazy, dw, and then the 1